Common rail fuel pumps, interesting topic and one that's talked about a little bit, but we've actually, generally speaking, we find that the common rail pumps themselves are ridiculously robust. So I just wanted to show you guys a little bit around the pump, how the pump actually works, and when we talk about a suction control valve, why they're so critical to the overall engine performance and engine running. So first things first, this is the overall pumping piston the pumping piston part of the pump. So basically, they're nothing more than a radial piston pump, and there's nothing else in them. They're very, very, very basic as far as the actual pump is concerned. And it's actually for the reasons that the fact that they're so basic is that's half the reason why they're so robust. There's very, very, very rarely a problem with the pump themselves. Okay, if you've had heavy water contamination or you've had really heavy actual particle contamination, obviously we're going to have problems with the pump. But if everything's been okay and the water ingress hasn't been all that significant and things like that, generally speaking, we find it's just the suction control valve. So this is how the actual system of a pump works. Now, the main thing I want you guys to understand is that actually when people talk about, oh, when you fit a 2-micron filter system and how bad that is and all the rest of that sort of stuff, they're actually a really good thing, but you need to pick a filtration system with the right flow rates. And that'll be a separate video in just a minute. But the main thing is they actually run a supply pump in the back of the fuel pump. So what happens is the fuel comes from your filter down into this little tiny feed pump, which operates just like the oil pump is in the sump does. That feed pump then supplies the suction control valve. Then the suction control valve supplies the radial pistons, which then pump it into the rail. A suction control valve is a massively important piece of equipment when we talk about the common rail system at large, really. And if you think about it this way, if we run, say, a V8 fuel pump and we're running this thing at 100% load, which is 1600 bar, if you were to think about a common rail pump in the way that you would look at a petrol pump feeds 100% all the time. You've got that little electric pump in the tank and it flows 100%, and we just return to tank what we don't use. But in common rail, we're talking 1600 bar, 1800 bar, 2100 bar in some of the new stuff by a significant volume of fuel. Now, I know for, say, a 79 series, 100 series, or 200 series Land Cruiser, 1VD, 1600 bar by that volume of fuel actually takes, say, 12 kilowatts of energy. If you think about that cruiser running down the highway, for that cruiser to maintain, say, 100, 110 kilometers an hour, it's only using 40, 50 kilowatts of energy, if that. So if you were to stack that 12 kilowatts of useless energy that we're just going to bleed back to the tank because we're not using 100% of the pump, the actual fuel consumption of that engine would be much higher, and the engine would be just so much less efficient. So if you think about it this way, the suction control valve, it's actually a metering valve, but what it really is doing, it's acting like the throttle of the pump. So the feed pump supplies everything, but basically the suction control valve only lets a very precisely metered amount of fuel through to the pistons that are then pumped, which uses all the energy, to the rail. So what actually happens, the ECU looks at the rail pressure sensor at the front. It looks at all various, in terms of, okay, that's what my rail pressure is at the moment. It then looks at all of the various input factors such as throttle, load, temperature boost, and all those other sorts of things to generate a new target rail pressure. And then that target rail pressure actually will activate the suction control valve, and the suction control valve and the rail pressure sensor work as a closed loop system in order to regulate the rail pressure itself. So this is why when these things start to play up, they give you quite a lot of bloody dramas, because they have the capacity to really, really, really overpressurize an injection system. And the actual really cool part of it is that actually between every single stroke, the little piston that moves up and down in here, which gives us our valve opening position, actually goes back to the home position every single time. So it's not like it just is meterly controlled just here. It actually will go all the way forward, meter the amount of fuel, come back to home position, and that's between every single stroke of the piston. So if obviously with a V8 you run 3 pistons, it's moving 3 times per revolution. So by the time they get to like 200,000 kilometers, they've done literally hundreds of trillions of tacks. Like, it's a remarkable the amount of work that they do, and they do it in such a finite fashion. But like I say, suction control valves, They're an incredibly important part to the common rail system at large, and that's why they can give so much grief. So when next time we talk about suction control valves, you guys have a bit better understanding about how it works and why it's so critical to the system. So I hope you guys found that interesting.